Hi friends, myself Keram Kumar. Now I'm going to explain my project. My project title is Optimal Performance Analysis Enabling Open Shortest Path First and Border Gateway Protocol in Internal and External Wide Area Network. I'm, I, I did my project in BSNL RTTC. My project is GNS3 project. My objective of my project is to make the fast convergence of the wide area network by enabling the interior gateway protocol called Open Shortest Path First protocol to ensure the quality of service for the wide area network and to analyze the performance of the multiple wide area network by using the exterior gateway protocol called border gateway protocol. Existing methodology. In existing methodology, they implemented within the autonomous system, and also the routing protocol works as per the basic routing protocol properties. Problem identification. In existing system, we can use only limited hops, maximum 15 up to 15, and also they use basic routing properties. Proposed methodology. In proposed methodology, we used multiple wide area networks, converge the net converge the multiple networks using open shortest path first protocol, and also converge the multiple autonomous system by using exterior gateway protocol called border gateway protocol. By converge the both internal and external wide area network by using routing redistribution. Routing redistribution is the concept we can which is used to redistribute the route from different route between different protocols. On my software configuration is my software configuration on my simulation softwares. Protocol structure. OSPF, Open Shortest Path First, is the fastest routing protocol which is used to improve the performance of the routing. In Open Shortest Path First protocol, we use area and L as a link state advertisement are used to make the fast convergence in the network. Border Gateway Protocol. Border Gateway Protocol is used to connect the exterior gateway networks, which means different autonomous systems. BGP are classified into two types. One is eBGP, that is exterior border gateway protocol, which is used to connect the different autonomous systems. Another one is interior border gateway protocol, which is used to summarize all the eBGP networks. OSPF protocol. Open Shortest Path First is a link state routing protocol for internet protocol networks. It uses a link state algorithm and fall into a group of interior routing protocols which operates within the single autonomous system. It gathers the link state information from available routers and constructs a topology map for the networks. For large network, we can split the large network into small group of areas for improving the efficiency of the routing. The area consists of backbone area, area border router, that is ABR, and autonomous system boundary router, that is ASBR. OSPF router types. OSPF has three types of routers. They are backbone router, designator router, and backup designator router. This is OSPF area topology, sample OSPF area topology. Here OSPF area 0 is the backbone area because all the other areas can combined by using the area 0. In this diagram, R2, that is router 2 acts as autonomous system boundary router because it combines both area 0 and area 2. The router which combines more than one area is called uh, area border router. And here R3 also the area border router because it connects area 0 and area 1. Here R6 connects different autonomous system networks, so it will access autonomous system boundary router. Next, border gateway protocol. BGP is a standardized exterior gateway protocol, that is EGP. BGP is the routing protocol choice of the internet. BGP is the one and only protocol which is used to connect the exterior networks. BGP utilizes TCP for reliable transfer of its packets on port 179. BGP peers, also called as BGP neighbors. BGP routers, otherwise called as BGP speakers, must form a neighbor relationship in order to make communication between one network to another. There are two types of BGP neighbors relationships: IBGP peers and EBGP peers. IBGP peers, BGP neighbors within the same autonomous system. EBGP peers in the sense BGP neighbors connecting the separate autonomous system. BGP peer messages. BGP forms its peer relationship through a series of messages. First, it sends an open message between peers to initiate the session. The open message contains several parameters such as BGP version. Version must be same between BGP peers. Local autonomous system number, BGP router ID. Keep alive messages are sent periodically to ensure the remote peer is still available. If a router doesn't receive a keep alive message from a peer for a whole time period, the router declares that peer is dead. Update messages are used to exchange routes between the peers. As a BGP peer session is forming, it will pass through several states. The process is known as BGP finite state machine, FSM. BGP states are ideal, connect, active, open sent, open confirm, established. Ideal in the sense it is the initial state. Connect, BGP waits for a TCP connection with the remote peer. If successful, the open message is sent to the peer node. If unsuccessful, the session is placed in an inactive state. Active, BGP attempts to initiate a TCP connection with the remote peer. If unsuccessful, an open message is sent. If successful, an open message is sent. If unsuccessful, BGP will wait for a connection retrieve timer to expire and the session is placed back to the connection state. Open state. BGP has both established the TCP connection and sent an open message and is awaiting a reply open message. Once it receives the reply open message, the BGP pair will send a keep alive message. Open confirm. BGP listens for a reply keep alive message. Established. The BGP pair session is fully established. The update message containing routing information now it will be sent. Module description. I have 5 modules in my project. First one is designing wide area network, assigning IP address to the host and routers, implementing open shortest path first protocol, implementing border gateway protocol, analyzing all the routing protocols. This is my project topology. Here I used three autonomous systems: autonomous system 100, autonomous system 200, and autonomous system 300. In autonomous system 100, I implemented open shortest path first protocol, and autonomous system 200 and 300 I implement both RIP and AIGRP. In this diagram, in autonomous system 100, I converge all the routers by using the open shortest path first protocol, and autonomous system 200 and 300 I converged. For converging the external gateway networks, I use BGP protocol, and then I will make converged. This is the method to assigning IP address to hosts by using VPCs. Assigning IP to routers. First we have to change the user mode into privilege mode, then privilege mode to global configuration mode, then global configuration to interface mode. Then we have to assign the IP address for that particular interface. This is the example for assigning the IP address for particular interface. Configuring the open shortest path first protocol. First I have to give the router OSPF command, and 10 is the process ID for that router. And redistribute command is used to make communication between different protocols. And network ID, we have to assign the network ID for making the convergence. This is the example for assigning implementing the open shortest path first protocol. Configuring BGP. BGP, we have to give the router BGP, then router ID, BGP autonomous system as 100, BGP log neighbor changes, and here also I implemented router redistribution, and also mentioned my neighbor autonomous system address and autonomous system IP. This is the example for implementing the BGP. A performance analysis. Performance analysis can be done by implementing the following factors. First, choosing the exact hardware requirements such as cables, switches, and then modifying the parameter or metric value of the routing protocols such as cost. Then modify the parameters of the routing protocol such as hello time, dead time interval, etc. Manipulation of parameters. The default value for OSPF metrics parameters as follows. By default, the hello time of the OSPF is 10 seconds and dead time interval is 40 seconds. We can able to modify the parameter value, and we can make improving our performance and convergence of the network. This is the result with the default parameter values. In default parameters value, I get minimum 468 milliseconds, average 461 milliseconds, and maximum 788 milliseconds. This is the result after changing the parameters value. I get minimum 100 milliseconds, average 553 milliseconds, and maximum 760 milliseconds. These are all the reference. Thanking you.